And welcome back, AP Calc students. Time for another FRQ, free response question from an old AP exam. The question we're looking at today is from 2019, and this is question number 3. Question number 3 means no calculator, and this question is a bit of a hodgepodge of skills. Definitely fits under the category of what I call potpourri because there's so many different aspects of your calculus knowledge that get used. It's really hard to categorize just one thing. So we have a little graph here and multiple integrals and a limit and lots of stuff going on here. And this is not just a potpourri, but it's actually very puzzly in nature. And we'll get through it. And but they seem to be drifting more toward this style, and so this is a really good one to focus on. What the question says is the continuous function f is defined on the closed interval from -6 to 5. The figure shows a portion of the graph of f consisting of two line segments and a quarter circle centered at the point 5, 3. It is known that the point 5 or 3 minus rad 5 is on the graph of f. So let's look at this and just get a feel for what's going on first. So let's look at what they have. We have a blown up version of the graph here. Now the problem says that the graph is going from -6 to 5, but they're only giving us -2 to 5. So you immediately just want to be thinking kind of out loud. You want to say, well, according to the problem, this is going from -6 to 5, but they're only giving me from -2 to 5, this is all we have from the graph. And so it's a bit of a mystery what's going on here. We could possibly presume that this line keeps extending, not sure. And so then the part they're giving us here, this is broken up into a chunk from -2 to 0 is this little line, and then from 0 to 2 is this line, and then from 2 to 5 is this quarter circle. So there's lots of stuff going on here we could see. The first thing you want to notice here is that this little line right here, it's got a slope of -1, and it may come in handy, maybe not, but it's so easy it just kind of jumps out at you that would be the line y is equal to -1x minus 1, because the slope is -1 and the y-intercept's -1. So that's what we would have right there. From the other section right here, this is also one you can probably do in your head. If you look, it's a positive slope, and we rise 2, run 1. So it's got a slope of 2 and a y-intercept of -1. So this is just the line y is equal to 2x minus 1, just by looking. And then here they say we have a quarter circle. Well, if you have a quarter circle, your geometry knowledge should tell you, and by the way, it does say that it's centered at 5, 3, right here. You should know that the equation of a circle is going to be x minus 5 squared plus y minus 3 squared, and we just have to figure out the radius. And we could figure out the radius maybe just by looking here. If this is the center, 5, 3, then you can see pretty clearly that the radius must be 3, so this must be 9. If you wanted, you could take the coordinate they gave you, substitute it in and get it, but we have our 3 portions of the graph, and we may need them, we may not, but they were kind of pretty easy to just generate. And then again, it's sort of a mystery what's going on here. So we've got a feel for it so far, okay? So now let's see what they say. They say for part A says, if the integral of the entire thing, so if we integrate the entire function from -6 to 5, it's going to give us 7. They want to know just the integral from 6 to -2. So I'm going to actually draw a second number line right here just to give us a feel for this part, make sure we understand this. So from all the way from -6 to 5, okay, if we were to integrate the entire thing, according to the problem, we would get 7. The question is saying, if you go from -6 to -2, this is what they're wanting to know. So this is what the question mark is. Okay, or we could call this x. And so would logic tell you that if we could take 7 and subtract off this, we could get x. And in fact, this represents the graph. So if you look at this, and there's the graph, and the assumption is we know enough geometry that we could figure out what the integral here would be, and then we'll just go 7 minus that and figure it out. That's the approach they're wanting you to take. It's connecting the definition of integration, an integral, with graphical area under a curve, and let's see if we can figure this out. So, looking at the picture here, if we were going to integrate from left to right, I think you can see for this part of the graph, we could actually integrate each one of these pieces if we wanted, but we might run into a problem integrating the circle, and these lines here, maybe we could use them, maybe not, but let's see if we could set this up, and then maybe we'll use geometry, maybe we won't. So let's just set up the integral from -2 to 5, and once we get that, we'll subtract it from 7. And so if we said, well, let's integrate from -2 to 0, and that function was -x minus 1. If we integrated that function, and then we added to that the integral from 0 to 2 of the next function, 2x minus 1, and then we added to that function the integral looks like from 2 to 5, and I'm just going to put this in here even though this might not make a whole lot of sense. If we had to solve this thing for y, we would subtract this over and root both sides, and this would be the bottom half of the circle. So instead of putting that in there, and I'm going to tell you right now, we wouldn't integrate that. I'm just going to put in the word, or I'm just going to actually literally write the quarter circle, dx. This is just slang here. This is what we're doing. Okay, and we're going to see whether geometry is the best approach, or should we actually use the integral. Now in this one, you might want to go ahead and use the integral. It's up to you, but the geometry on it's really easy, because if you look here, you have area under a curve. We have this little triangle, and we have the other triangle below. So remember, keep in mind we have the x-axis here. So area under the curve, we would integrate. We would have this part, but then we would also have this part right here. And these would wind up canceling each other out. So if you integrated from -2 to 1, or sorry, from -2 to 0, this part of the integral, that's just going to give you 0 by geometry. And again, if you wanted, you can integrate it, you get the same thing. Now this one right here looks like you're going to have area under the curve, so you're going to have this negative part right here, and then you're going to have this positive part right here. And that's not looking real friendly. This one might be a portion where you'd say, I don't know, whatever that value is, figuring out those, maybe I don't want to do that. Maybe the integral will be easier. And you probably argue both ways, but I think the integral is easier here. And so let's go ahead and integrate that. So let's add 1 to the exponent divided by a new exponent. This one you're getting x squared minus x, and we'll evaluate that from 0 to 2. Pretty simple integral. Put 2 in. You get 4 minus 2 is 2 minus 0. This little integral here just equaled 2. So we have a 0, we have a 2, and then we have this quarter circle here we got to deal with. So if we look at the quarter circle, you got to be careful here. The only part of the quarter circle that we are concerned with here, remember this is the exterior of the circle between that and the x-axis here. So what I want you to look at is look at this square that's made right here. Okay, that's 3 by 3. This entire square here is 9. Okay, so I have 9 minus a quarter circle. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The whole thing is 9, and then I'm going to subtract from it a quarter circle. So for this part right here, I'm going to say, well, it's 9 minus, let's see if we can figure out the quarter circle. This radius was 3. So the area of the full circle, so I'm going to say a sub c, the area of the circle would be pi r squared. So that would be pi, the radius is 3, times 9, or 9 pi. So we want the area of, I'm actually going to put the quarter circle, and so we just divide this by 4, and we would get 9/4 pi. So this quarter circle right here, and I think I'm going to highlight that in orange here. this part of this is the quarter circle that we're subtracting off of. Okay, that is equal to 9/4 pi, because the whole circle was 9 pi. We just need a quarter of it, so divide by 4. So that's that part right there. Then we have this entire square here, which was 9. So 9 minus that little guy would give us the area we need. So I hope this wasn't confusing. When I said the quarter circle, I was just I'm not saying I needed the area of the quarter circle. I was just meaning this last little region. I was slangily calling it the quarter circle chunk here. Okay? And so if that confused you, I could even say, I could tweak it here, and I could say this last region was going to be a square minus a quarter circle, because that's actually what we did. Okay? So it looks like that's what I have for my area. If I add all of those up, 9 plus 2, it looks like the entire area here, if I just integrate by geometry, this whole part turned out to equal 0 plus 2 plus 9 minus 9 pi over 4, we would get 11 pi over 4. So I'm going to say the integral from negative 2 to 5 of f of x dx is equal to 11 minus 9 pi over 4. Okay? Now I'm not done, I need that value here, because the question said if the integral from negative 6, which would be about here, all the way to 5 is 7, figure out this chunk again using this number line. We want this part right here, and we just figured out what this part is, which is 11 minus 9 pi fourths. So I need to take the total, which is 7, subtract this off of it, and I'm going to get the difference right here. So this little guy right here is 7 minus 11 minus 9 pi fourths. Okay, so now I'll just distribute my negative through, and this turns into 9 pi fourths. 7 minus 11 is 4. Okay, so I have this part right here. It was given in the problem that negative 6 to 5 is 7, and so I'm going to say the integral from negative 6 to negative 2 of f of x is dx is equal to this down here, 9 pi fourths minus 4. This is the actual answer to that question. Okay, so we had negative 2 to 5, negative 6 to 2, and then the given, which I can just rewrite here just for the purposes of having it next to everything. The integral of the entire distance right here, that was equal to 7. And so what we did was we took this part, total, and we subtracted this part, and we got this part. So for our final part, the final statement, I would say, or not the final statement, but just if you wanted to communicate even more, you could say we took the integral of negative 6 to 5, subtracted off of there the integral from negative 2 to 5, and we got the integral from negative 6 to negative 2 dx, which was equal to this value right here. So now I'm going to take this out of the way. And I'll put that there again. So 9 pi fourths minus 4. Kind of involved there for just just for one question, one part of a question. Okay. Again, very puzzly in its nature here. Let's move on to part B. Okay, part B says evaluate this integral. This one's actually much more straightforward. And we get the integral from 3 to 5, and this is going to be 2 times f prime of x plus 4 dx. This was an unusual question where it actually had like some algebra of the integral involved. I'm going to take the 2 out front, make this a little easier to see. So if I factor out a 2, I'm going from 2 times the integral from 3 to 5, f prime of x plus 2 now dx. Okay, so this is actually a pretty simple integral. Okay, so I've got 2 out front. the integral of f prime of x is f of x. So it's 2 times f of x. The integral of 2 is 2x, but there's a 2 out front, so 2 times 2x is 4x. And we have to evaluate that from 3 to 5. Okay? So now we have, I'm going to substitute in right here doing the fundamental theorem, and just for space I'm going to move this underneath here. So I'm going to say this is going to equal 2 times f of 5 plus 20, so that's putting 5 in here, minus putting 3 in, 2 times f of 3 plus 12. Okay? Now f of 5, the way we figure that out is go back to the graph. Well, look what f of 5 is. It's just 0. So this becomes 20, because 2 times 0 is 0, minus, actually I'll put the 0 there, 0 plus 20 minus, now f of 3. If we figure out what f of 3 is here, f of 3, that sounds familiar. That's because in the original function they told us this was a coordinate, 3, 3 minus rad 5. So f of 3, this is annoying, we've got 2 times 3 minus rad 5 plus 12. Okay? So, simplifying this some more, what do we get here? We get 20, and then this is going to be minus 6. I'm going to distribute the 2 in there. 6 minus 2 rad 5, and then there's still a plus 12 there. Okay, so 6 and 12 is 18. 20 minus 18 is 2. I take the negative and distribute that in there, and I get 2 plus 2 rad 5. Now, there were so many opportunities to make a careless error on that one. That was really something, but that was B. Okay, so just kind of some straight integrals, reading the graph, arithmetic. I mean, there you go. Let's move on to part C. And I'm going to start part C way up high here. I think I can use some of this space here. And let's see what happens here. C says the function is given by, okay, we've seen this kind of thing before where they say g of x is defined by the integral from negative 2 to x of f of t dt. Okay, so new function g, just out of the blue, okay? Find the absolute maximum value on the interval from negative 2 to 5 and justify your answer. Okay, so basically what they're saying here is, you guys should know the integral here of f is equal to g. So what that means here in this problem, that means that the derivative of g prime, or sorry, the derivative of g is equal to f. Okay, because once, remember, we integrate this, the integral of f is going to be capital F, if you want to think of it that way. So I'm going to rewrite this over here. If we were to say the integral from negative 2 to x, if I were to say f of t dt, and I were to integrate that, I would get capital F of x minus f of negative 2. I would do it that way, integrating lowercase is equal to capital, but instead of that, they're saying it's a new function called g. Okay? So sometimes they do that just to kind of keep you on your toes here. They will call the integral instead of capital F, or instead of calling this g prime, they'll just have them different. But just know that that's the derivative of the other. So instead of going down that road, which we've had to do before, I want to show you why it's not real important for what they're asking on this one. So what they're asking for is, they want the absolute maximum of g. So I don't really care what it equals over here. If you want to know maxes and mins, and this one actually they want to know the absolute max, you want to think the following. Absolute max is critical numbers and endpoints. I'm just going to put critical numbers and EP endpoints. So what I need to do is go back up to here, and I have to say, well, if g of x is equal to the integral of negative 2 to x f of t dt, that's what's given, we need to take the derivative of this. So I need to take d dx of this to get my critical numbers. Well, the derivative of g is g prime of x. And now I'm doing this derivative of the integral. Now if you remember, when I retake the derivative of an integral, you got 4 things going on. technically speaking, this is going to be f of x times 1, because I'm going to replace t with x times the derivative of x, minus f of negative 2 times 0. And all of that drops out, and we get g prime of x is equal to f of x, which actually we already knew anyway. Okay, so we take our derivative of g, which we just did, because remember, we're looking for critical numbers, and now I'm going to get this out of the way. I don't think we need this anymore anyway. And now we're going to take this, and if you remember, we're going to set that equal to undefined and equal to 0 to get our critical numbers. Well, here's the function right here. When is this thing equal to 0? Well, you guys, there's your x-intercepts right there. It's never undefined, by the way. And when is it equal to 0? Just by reading the graph, it equals 0 at x is equal to negative 1. And this point right here, well, when did this equal 0? Well, if you remember, we had the equation of that line. I actually just had it here and erased it. I could do this off to the side. The equation of that line right there was 2x minus 1. So y was equal to 2x minus 1. And so the y value was 0. So if 0 equals 2x minus 1, I'll add the 1 over divided by 2. I get 1/2 is equal to x. Okay, and you could have figured that out also by, well, if the slope is 2, if I rise 1, I'm going to run a half. If I rise 2, I'm running 1, so there's a couple ways to get that. But you could have said, either way, you get a half. And plus, now I have to check my endpoints. So my endpoints are negative 2. So these are my critical numbers. And then I'm going to say plus endpoints, which are negative 2 and 5. Okay? Just won't want to be confusing here. Plus, I'll say, or I'll just put negative 2 and 5. But I'll just point out that those are endpoints. Okay? So one of those is going to be the absolute maximum, so we got to check these out. So here's what we're going to do. We are going to test. Let's see if we can make some space over here. Get rid of this guy. All right, and so here's what I'm going to do. I'm going to say, well, I'm wondering what is g of... I'll just go left to right. What is g of negative 2, which is an endpoint? And then I'm going to have to figure out what is g of negative 1. And then I'm going to have to figure out what is g of 1/2. And then I have to figure out what is g of 5. And we'll figure out which one is the maximum. Okay? So if we put in negative 2, again, our formula here is up here, which was given in the problem. And I'll put that right here again. Remember, g of x is equal to the integral from negative 2 to x of f of t dt. Okay, so it's a pretty simple integral here. So if we do g of negative 2, my integral is going from negative 2 to negative 2, f of x dx. Well, if your integral has no interval, if it's negative 2 to 2, it's just 0, so that was pretty easy. All right, let's try negative 1. We're going to integrate from negative 2 to negative 1. F of x dx. Okay, so now we can just go to the picture. Integrate from negative 2 to negative 1. Well, that's just that little square, but divided by 2, so that equals 1/2. Okay, g of 1/2. Okay, we're going to go from negative 2 to 1/2, back to the picture here, back to the graph. All right, let's go from negative 2 to 1/2, so we're going to this point right here. Well, negative 2 to 0, those cancel each other out, so we're at 0. So then what's the area of this little guy right here? Well, this little right triangle, that's 1. This is 1/2. 1/2 times 1 is 1/2, and divided by 2 is 1/4. And it's below the x-axis. So it's negative 1/4. Okay, make sure you get that one. And then g of 5, it seems like we did this already. I think we did g of 5, didn't we? Where we had to integrate from negative 2 to 5 of this thing. Wasn't that what we did with the very first question? We went negative 2 to 5. In fact, that's right here. We already did that. It's 11 minus 9 pi over 4. Okay? Now you have to figure out which one was the absolute max. Well, it's not 0, it's not the negative 1. So it's either -1 or 5. It's one of these two. So this is not intuitive, so you're going to look at that and go, well, I don't know, what is this approximately? It's going to be 11 minus, pi is about 3. 3 times 9 is 27. 27 over 4, pretty close to 7. So I'm just going to say 7-ish. So if it's close to 7-ish, I don't know, it's going to be 3 point something. And all I know is that that's bigger than a half. So here's your max right here. So the absolute max occurs at g of 5, which is equal to 11 minus 9 pi fourths. Okay, kind of brutal. Okay, so again, points in this one were kind of low. There's a lot going on here. Plus, it's taken a while to kind of pick through all of this. Okay, last part, D. Now, when you look at D, you should probably be thinking L'Hopital's rule. It's a limit. But you might be pleasantly surprised. Believe it or not, I couldn't believe they did this. This is a Nike limit, believe it or not. But you had to do just a little bit of work, but not much. But it really is a Nike limit. I just was stunned. So f of x minus arctan. Of course, the function's not too simple, but let's see what happens. So we just put in 1. Let's see what we get. So we put in 1. We get 10 to the first minus 3 times f prime at 1 all over f of 1 minus arctan of 1. Arctan of 1, where is tangent 1? You want to have that memorized. That's pi fourths. Okay? All right, so now we got to figure out what's f prime of 1. Well, let's go to the graph. F prime of 1. Well, this is f. The derivative is the slope. The slope right there, we already discussed it. It's 2. So what this winds up equaling right here is 10 minus 3 times 2, because that's the slope. And then on the bottom, f of 1. F of 1 right here, f of 1 is 1. So we get 1 minus pi over 4. So prepared to have this be 0 over 0, but it wasn't. So we get 10 minus 6 is 4. And so we get 4 over 1 minus pi fourths. It's not a calculator. If you want to get a common denominator, go ahead, but this is actually fine. I guess if you wanted, you could go 4 over, what do we get here? 4 over 4 minus pi over 4. And you could do 4 over 4 minus pi over 4. And so then I guess you could flip that up and you could get 16 over 4 minus pi. Do what you want. Either one of these is fine. Okay, so we'll just box that one. Okay, so again, an odd question. Lots of stuff going on here. We have some geometry with integration that was not the friendliest, and that was just even on the first one here. Probably the easiest part was B, just kind of some straightforward integration, and then C. Not the easiest, but after you see it, it's not too bad. But then you had to get your critical numbers. A little bit goofy here, a little tricky. And then the last one, the limit was actually pretty easy. So this is one where you don't lose hope. It actually has a nice ending here, and you could probably get half your points, even if you were struggling with parts of it. And so make sure you do everything possible. You don't have to get everything, but this was definitely a little bit kind of a quirky potpourri problem. So there it is, 2019 AP Calc AB question number 3. Thanks for watching. We'll see you next time.